The Ka times the Kb equals the Kw. That's it. So that's a formula that I would give you on the test.
And KW is
And Kw is
hydrogen
1 times 10 to the negative
concentration of hydrogen times
14.
Okay, yeah.
And I would tell you Kw on the test, but y'all are remembering that it's 1 times 10 to the minus 14. So if you know Kw, and you always know Kw, if you know one of the others
at 25
at 25 degrees
degrees.
Celsius, yes, because it changes depending on temperature. For example, the problem we worked last time, I told you that the Kb is 2.1 times 10 to the minus 11. So that's the base dissociation constant. Y'all know every base has a conjugate acid, right? And likewise, every acid has a conjugate base. So if that's the base's dissociation constant, what would its conjugate acid's dissociation constant be? You simply plug this in for Kb. You know Kw is 1 times 10 to the minus 14.
That divided by 2.0.
So you say 1 times 10 to the minus 14 divided by 2.1 times 10 to the minus 11. And you get 4.8 times 10 to the minus 4. What if I asked you to calculate the pH of a solution that is 0.050 molar fluoride ion? Well, you will, but directly. I'm sorry, that was a bad way to ask the question. Fluoride is the conjugate base of hydrofluoric acid. Y'all picked up on that. So what you're doing is you're going in the table and you're looking up the Ka. But the Ka would apply if we were using hydrofluoric acid. We're not using hydrofluoric acid, we're using fluoride. So why do I need that Ka? I need to use this to get the Kb, because fluoride's the base of hydrofluoric acid. To get to the base, don't y'all remember you take a hydrogen away and that gives you the base? Remember doing that when we opened up the chapter? So I'll look up the Ka for hydrofluoric acid, and I find that it is 7.1 times 10 to the minus 4. How do I get Kb?
About 1 times 10 to the negative 14 by 7.8.
Yes. I'm going to say 1 times 10 to the minus 14 divided by 7.1 times 10 to the minus 4. And I get 1.4 times 10 to the minus 11. What that is my Kb. Do you see why I needed a Kb for this one?
No. Oh, because it's just a base.
Because fluoride is the conjugate base of hydrofluoric acid. That fluoride is obviously not an acid because it doesn't even have a hydrogen. Yes? Okay, so now what do I do? Now once I have the Kb, can I solve for pH? Yes, because I know that Kb is equal to x squared divided by initial concentration, don't I? So I know 1.4 times 10 to the minus 11 is equal to x squared divided by 0.05. And I'm going to solve for x.
Slightly basic.
What do y'all get for x? 8.4 times 10 to the minus 7?
But that's the concentration of the hydroxide?
Exactly. That's the concentration of the hydroxide. If that's the concentration of the hydroxide, then I take the negative log of that, and I'll have a pOH equal to 6.1. And then 14 minus that gives me a pH of 7.9.